And eventually, if you insert at the end, right, current will move to point to null and previous will move to point to end, which is start to execute the code to add. If you review the code to add again, this is add as order, right, list. So it's going to be while colon not equals to null, now it's null, is no longer the loop. And if current is going to null, it's going to set the pointer of previous to the new node, which is going to do that right here, new node, right? Previous set to new node, and then we get the list back again in order. G, H, I, J, L, N, and O. Now, for your assignment, you still need to test. You can run the unit test, but let me make sure that we understand. We're going to create. I just explained this is linked list, right? Linked list can be many ways to add. Add as a stack, as an ordered list, add as a queue. It's just linked list. But in your assignment, you're supposed to create like a stack, which is I have stack here and interface, right? Is that interface? Yeah, that's the stack. Yeah, that's one with this operation push pop top, right? And you're supposed to create another stack, right? One stack with array, one stack with, this is using array stack. And the stack itself, if you want to be not confusing, that linked list stack, I can just refactor, rename it to LL stack. Okay. You have to do to separate. And LL stack, of course, do the same, like implement I stack, which exactly the same with array stack. You're going to implement I stack. All right, and then you have to add an implemented code, right, into that, which is right there, right? And this has to be an E. Okay. Now you have to declare an array to do this, right? You have to do enlarge because this is unbounded. You have to create a method called public void enlarge. It's not public, it's private because it's only do inside here. We're not sharing that. Enlarge, okay? Enlarge pretty much just copy the old one to a new one that's bigger. And you have to create an array in here with the initial size, like you have to create a constructor, public array stack. This is a constructor, and you pretty much just initialize the list right here, which is E list equals to new. This is an object, right? An array of object, and cast back to E, right? New object with the caps. Like we can say, okay, let's create private int cap equals to 100. So it's going to be initialized cap right there, right? And then has to cast this back to E, right? And it has to be cast as line array. And an array, this is an array, so casting actual parentheses inside here as an array. Now, you have to do push as array, pop as array, and top like what I used to show you, right? And it's empty in size, and enlarge to make sure the size change. And you should have the overloaded array, which the user can specify its own caps, right, inside. So this gonna be like that in state, right? And how to implement enlarge. To enlarge is pretty much just like whenever you keep pushing, we have to check if it's full. Like we have is empty, we should have is full, right? If it's full, then how do you know that it's full? Public. We don't need to have public, it's just used locally because it's unbounded. Private boolean is full. So how do you know it's full in the array? Return the size equals to the list dot size. We have that, right? Right. Whenever you add, you keep increment. When you push, you keep increment. Like the size plus plus, right? When you do remove, you also decrement. We have to do size here. Let's us make sure that we're not confusing about the name here. This is like the this is a capacity then. Okay. Size mean how many things in your array. When you push, you add the size. When you pop, you do the size minus minus, right? And then we can say size equals to, if the size equals to just index. Whenever you add, you're going to have the index because this is an array, right? So size pretty much just like an index. If it happen to be equals to your cap, right? So let's make sure we know that cap can be changed. So this cap equals to capacity then, right? So if it's happen to do equal to the cap, not sure it's a good idea to do that because we enlarge, cap always change. So what we look at, size equals to what? So now size equals to cap, that means full, right? If is full, right? If it is full, what do? You call it large. Then this array is never full. And then you start to do whatever you need to do in the code. Enlarge is the one who's going to create a bigger array and copy the old one to the new one, right? And you're going to do the same for, we have stack, we're going to do queue. You have to do LLQ, right? LLQ is going to implement the IQ interface, right? Like it's going to be NQ and DQ, which I have to do IQ, right? And we're going to do another one, which is array Q. And same array Q is going to implement to IQ interface. Like I have iStack, push pop, IQ going to have same instead of push NQ DQ, right? Size is empty, exceptions. I'm going to create another one for order list, right? So we're gonna say LL ordered list, which is the implementation, just like I try to show you in the linked list, right? And this has to implement I list, and it's going to have to do, and of course all of them has to be generics, right? I mean interface list caps I, and then it has to implement that in the way that I just explained you how to add and remove in here with linked list. And then you have to do new Java class array using array, like I try to show you how to create an array with a stack, same pattern here. Array ordered list, and the same, it's going to implement the same interface, but implementation is going to be different because you're using array, okay, which is I list E, right? And then has to implement the interface now. But you have to do it the way that array does, which is different than using linked list. And then you still have two more, which is what? Array indexed list. Of course, it has to implement iList, and this iList has to iIndex list, which is extends from iList, has the index as the parameters when you add now. And then you have to do linked list for index list, right? And implements that iIndex list and add other method here. And test each of those in your unit test, other method, other classes. After you've done all the tests, it's supposed to show me greens for all of them. When you submit, I want to see it's all green, like, okay, run that test at the top level, right? There's an errors here. We have to fix them before we can run them. Extend comparable. All right, so okay. Unexpected. So extends. Since this has to be comparable, this element has to extends comparable. Okay. Same here. All right. So when we run the test, like I'm gonna go to the top of the class, run everything. I want to run the test. If it's red, then you're in trouble. Like those are good, you pass, but of course you pass because you didn't write anything. But if you write, you're supposed to write, I'm going to see your code. And if you have red, that means you're not passing the test. So you lose your point. So I want to see all the tests, all the greens, then you get checked for all of those 8 classes and other sub-method for those classes. And lastly, go back to your assignment 1 application, modify the list that you used from the models. Instead of use array list, pick one, array index, order list, array or stack, or linked list, order list. Use that here and make sure your application is still running as normal after you switch out, and explain why, put in description why you want to pick that out of 8 types to use in your user list from assignment 1.